Broadcast is now starting. All attendees are in listen-only mode.
God morgen og velkommen til dette RF-elements-webinaret i regi av Ontis. Mitt navn er Asle Kristoffersen, og sammen med oss fra RF-elements har vi i dag Mikael Mardiak, som er Product Manager hos RF-elements. Takk for at dere har tatt dere tid til å delta. I vårt forrige webinar hadde vi en gjennomgang av RF-elements sine tvistbortløsninger og symmetriske sektorattender. I dag så skal vi ta en liten titt på RF-elements sine sektor carrier-klasseantenner. Tidsmessig så regner vi med å bruke 30-35 minutter. Still gjerne spørsmål underveis, men jeg foreslår at vi tar en gjennomgang av spørsmålene på slutten, sånn at vi får litt flyt i presentasjonen. Mikael han presenterer jo på engelsk, men det er bare å stille spørsmål på norsk, så skal jeg gjøre mitt beste for å få oversatt det. Så er det noen spørsmål dere har, så er det bare å skrive det inn i spørsmålsfeltet i webinarapplikasjonen. Vi gjør opptak av webinaret og legger det tilgjengelig for dere i ettertid, mest sannsynligvis på YouTube. Da gir jeg ordet til Mikael. Good morning, Mikael, and thank you for taking time to talk to us today.
Good morning, everybody. Thanks for organizing this webinar. So, let me introduce again. So I'm Michael Mardiak, I'm from RF Elements. I'm product manager here. So I will be the presenter, or I will be speaking about the sector carrier class antennas. So first of all, really short about our company. RF Elements is based in Slovakia. We have two sites there. One is headquartered in Bratislava, another one is an engineering site in Humene, and then we have also a representative office in Austin, which is in Texas in the United States. Our main focus is innovation. Our products look different, they work different because simply they are different, because we are innovative. We are manufacturing wireless network equipment, but today I would like to speak about one of those equipments, and it's sector carrier class antennas. So what does it mean, sector carrier class by RF Elements? There are two essential things that you have to think about when we are speaking about RF Elements, sector carrier class antennas. First is that sector carrier class antennas are designed to be excellent for a cluster deployment. Currently on the market, there are no other antennas in the same price category that are made for cluster deployment. With sector carrier class antennas from RF Elements, you don't need to buy anything else. So no additional items, no additional cost if you would like to do a cluster deployment. It comes like that from us, from a manufacturer side. Second thing about the sector carrier class antennas is that they have a perfect horizontal and vertical beam performance. And let me explain how these two things work in more detail. So first I would like to explain you a collocation ability. So the key for a collocation ability is a backshield. Backshield is our patent pending technology that attenuates the side lobe and also the back lobe. And we were able to achieve this by using a special frequency selective surfaces. This backshield technology is really a highly effective system, and it was optimized by high-class software, and we developed that for a long time. So the key is the special frequency surfaces, and these surfaces are optimized for a particular frequency range where these antennas work. So if you have a 5 gig antenna, the backshield technology is optimized for that particular frequency range. And these surfaces, they don't reflect the radiation, but they suppress it. The backshield technology comes integrated with antenna body directly from a manufacturer. So again, you don't need to deal with this anymore. You don't need to pay anything else. It comes like that. And this is a practical implementation of a backshield technology. This is a cluster deployment demonstration. And here you can see then that when you are using a backshield, or by using a backshield, we suppress the side lobe as well as a backside radiation, and thus the collocation is very easy. Because collocation with other antennas that are not designed for a collocation, so they are inappropriate for such a purpose, it's really hard, and even it's impossible to do. And I would like to show you what I meant by inappropriate antenna. So this antenna is a very popular antenna. It's typical antenna. It's a lot of them. It's outside on the people are using, and it is a antenna from a Ubiquiti, and this is a AirMax 5 gig antenna with a 19 dBi gain and 120-degree radiation angle. And here you can see the side lobe and back lobe. So for those who don't know, it's a blue radiation that you can see slightly on the side and also on the back side. And this radiation is unwanted radiation. This causes a lot of RF pollution, and this is the problem. So this is an issue when you are doing a collocation, not the radio, but antenna transmit the signal all around, and that's the problem. But our approach is different. We integrated this approach in every sector carrier class antenna with almost no additional cost. And here you can see how effectively it works. This is a simulation of radiation or radiation pattern, or how the antenna radiates the signal. And important thing that we also achieve it with almost the same amount of the material. So antennas are still, as you know, compact and light antenna. So I think that these pictures speak for themselves how effectively we are, or how effective is a backshield technology. And I would like to mention one more thing, and it's a third-party shielding. And there are a few reasons why I would like to mention this. So first, simply it doesn't deliver whole job. So one of the most used shielding on the market is RF armor shielding. Basically, it's a big metal construction that surrounds the antenna. And as you can see on the simulation, it kind of works, but it doesn't do what it should do. And also, here you can see the backside radiation and side lobe are very slightly suppressed, but what's really a problem that the third-party shielding here, the RF armor, affect not just the back radiation but also the front radiation. So whole radiation pattern of antenna is changed, and that's the problem. So you don't really want to have it. Another thing about the third-party shielding is that it's basically a huge mess of the material. So somebody need to climb with that to the tower and mount antenna with such a big metal construction on the tower, and also it burdens the tower. So that's also problem when you have an issue with the wind load. And the last thing about the third-party shielding is, of course, the price. Sometimes the shielding costs same as the antenna. Just to mention here, the prices that you see above the image in the middle, so above the one with RF armor, it's the price for both things, so antenna plus the RF armor. And here is the answer for a third-party shielding. So why people are using it, so reason is also simple, because the antenna designer, they don't do their work well. If they did, the antenna will look like the one on the right side. So you don't need to pay anything else, and the shielding is integrated with the antenna body. And comparing also with the price, you can see that sector carrier class antenna from RF Elements are really unbeatable if you compare it also with the price and performance. This is how we deal with the side lobes and the back lobe when we were designing a sector carrier class antenna. So that was the first essential thing. So something which is on the back and the side, how we depress the side lobe and backside radiation. The second essential things about the sector carrier class antenna is perfect beam performance, so the front radiation. And the key for perfect beam performance is that the horizontal and vertical beam patterns are as identical as possible in terms of radiation patterns and gain. And I'm speaking about this because currently the majority of other antennas, they don't have such a beam performance. So it means that the beam pattern differs, the radiation differs in every polarization, the gain is strongly dependent, then also the gain is different for every polarization, and that's the problem for a MIMO. With such an antenna, you have in different place different coverage and different gain, and that has a strong impact on the MIMO performance of the sector. And since there are a lot of antennas out, maybe or people start to think that it's something which is common, but it shouldn't be so. It shouldn't be the standard. The antenna should have a perfect radiation or beam performance. And this is a practical example, another one. And the beam performance is not just the problem of low-grade antennas or cheaper antenna. Actually, this one is an antenna from a Ubiquiti, the AC sector. There is also a model written. And the MSRP price of such an antenna is around $200 US. And you can still see that even such an antenna has a problem with the beam performance. You can see a few things here, that for a vertical polarization, the radiation angle is much wider than for a horizontal one. So it differs, the radiation angle differs for every polarization. And also you can see that the horizontal polarization, the beam in horizontal polarization is going slightly to the left. And that's the problem, because then when you plan your network, it's very hard to plan it so the CP on the other side will have a coverage from both polarization. On the other side, you can see our antenna. So the beam performance, the horizontal and vertical radiation angle is as close as possible. Here you can see it also in antenna patterns. This is the reason why our sector carrier class antenna excellent when it comes for a MIMO performance. We have a lot of questions about the beam width. So our antennas, so this is the beam width for a 17 dBi model. All other models have a very similar beam width. It differs just in a few degrees. And we have a lot of questions why we don't have also different kind of radiation angles. So we have just this 100, and the reason is that if we do such an antenna, so 90 degree, 60 degree, or even less, the antennas will have the same issues as I was talking about. So 100 degree antenna is optimized to have a balanced gain and uniform gain, and also the radiation pattern are as close as possible. We have also a 3-chain model of a sector carrier class antenna, and we have it because there is a 3-chain radio. The radio is a net metal from a MikroTik. So we were thinking how to use it, so how to use a 3rd chain, and we decided to use it like that. We added one horizontal or one vertical polarization. So there is no slant polarization. We didn't add slant polarization. So we have 2 models. One is with the 2 horizontal and 1 vertical. Another one is with the 2 vertical and 1 horizontal polarization. The reason why we have it is that this kind of antennas might help you in some situation. First is when you are facing a lot of reflections in one polarization. So for example, if you are facing a lot of reflection in a vertical polarization, adding additional vertical polarization, so the chain with the vertical polarization, you will be able to collect more reflections from the CPE side, and thus you will be able to receive more data. Also, it might help you when you are facing a lot of interferences in one polarization. So for example, if you are facing a lot of interferences in horizontal polarization, adding additional horizontal polarized chain will allow you to collect again more packets from the CPE side, and thus the throughput might go up. The sector carrier class antennas are made from a solid construction. So it's all made from aluminum. We have a stainless steel hardware and also a UV resistant ABS plastic. And we don't use any surface treated material because we know that the customers are using our antennas in different kind of weather conditions. So there is nothing to corrode. Also the brackets are made from aluminum. The antenna is extremely light. It only the biggest one only weighs 3.1 kilograms, so it's really light. And one more thing, or 2 more things about this antenna is that it comes with the pigtail cover. And maybe you are wondering why I'm mentioning this. So I don't know if you know, but RF Elements was the first company who used a pigtail cover on our antenna, and now everybody is using, so we inspiring a lot of people. And another thing about this antenna is that every sector carrier class antenna come with integrated pigtails. So you don't need to buy pigtails. It comes with the antenna, and it's integrated with the antenna body, so we reduce the number of connectors by 2 in comparison to other antennas. Of course, we know that the customers are not always choosing antennas based on the collocation ability and beam performance, but usually customers are considering more factors. So we know it, and that's why we prepare this scorecard. It's a comparison between most used antenna from Ubiquiti and our antenna. And here you can see how sector carrier class antenna perform comparing to other antennas. So you can see that VSWR is it's lower in our antennas. As I mentioned, we are using just high quality materials, so you don't need to worry about the weather or something like that. and also the antennas are extremely light, and it comes with a very good price comparing to other. We also have a lot of questions about the cambium sector antennas and our sector carrier class antenna. The reason why we received those questions is because they look very similar. The reason for that is also the cambium sector antenna has integrated backshield. They are not breaking any patterns, we allow them to use it, but that's the only thing that these antennas have in common. They'll just look the same. But otherwise, these antennas are completely different. The backshield technology on our antennas is much more sophisticated. We spend a lot of time to develop it. So even if the backshield technology looks same, our is much more sophisticated. And this is a lot of metrics that to compare with the cambium sector antenna, but what is most important is field performance. And with the comparing to the cambium one, our sector carrier class antennas are incomparable in performance. They perform really good, and also feedback from customer, we don't have any complaints about the performance. I would like to guide you briefly through our antennas model. So for a 5 gig spectrum, we have and 2 chains antenna, we have 2 models. One is a 17 dBi and another one is a 20 dBi model. Why we have 2 models? The philosophy behind it, it's different. So it's not always good to choose the biggest or the antenna with the biggest gain. People should choose or use a reasonable gain antenna, because when you use the big one or the biggest one, you can create a lot of interferences for the others, but as well as for you. So that's why we are giving you an opportunity to choose the model if you would like to have a 20 or a 17 dBi model. And also here you can see the antennas gain, and you can see that for 17 dBi model, the gain is much more uniform in the whole 5 gig spectrum. So if you would like to use it below frequencies 5.45 gigahertz, then you should pick a 17 dBi model. We also, as I mentioned, we also have a 3 chains antenna, 2 models, both with a 16 dBi gain. So one is with 2 horizontal and 1 vertical chain. Another one is with the 2 vertical and 1 horizontal chain. And here you can see the antenna pattern as well as gain. So still the gain and antenna patterns are as close as possible. Maybe you can't see the good in detail. So if you would like to check it in more detail, you can go to our web page. All these data are in our in the data sheets for the antenna, so you can check it there in more detail. Then this one is for the second model. We also have one model in 2.4 gig, so it's a 14 dBi gain antenna model, and here are the radiation pattern and gain. Since also this antenna is sector carrier class antenna, it comes also with the backshield technology that is optimized for a 2.4 gig range. What you can connect to the antenna, so for those who are using a MikroTik router board, we have a Station Box S carrier class. It's an aluminum enclosure where you can put a router board, and it's directly compatible with sector carrier class antennas. When you are using a Ubiquiti Rocket M5, so we are also offering a rock shield, which is additional shielding for a Rocket M5 radio. It's very light and it's wrap the radio, and it offers you additional shielding. Sector carrier class antennas are also directly compatible with major ubiquity Rocket radio, so you don't need to use any additional hardware. You just simply can connect the radio on the sector carrier class antenna. Also, antennas are compatible with a microtic, so on the base box, net box, or net metal, but you have to use a tiny plastic bracket. It's called an easy bracket 912. And if you are using a cambium radio, you can also put it on the sector carrier class antenna, but you need to use an easy bracket for ePMP. And this is the installation of such a bracket. It's very simple. So you just screw it from inside, and then you can connect it to the antenna. This was about the model, but I would like to share with you one customer use case. So the customer use case is from Blue Spam Wireless Company, which is a WISP in USA, in Arizona. And this WISP, they grow very fast. So their growth rate of in the last year was 540% per year. So they decide to build a brand new site, and this brand new site, they use our sector carrier class antennas, the 17 dBi model, and they use it with microtic net metal radio. And since they are growing really fast, so they at the time they wanted to try our antenna, because they were looking for a better RF performance, and as well as improve the installation, so the whole process of installation, so to shorten the deployment time and ease of installation. And the reason is simple: they are growing really fast, so they need to save time with this. So they decide to go with our sector carrier class antennas, and what they achieve. So here you can see the cluster deployment they use for antennas to cover the area around the tower. And they were able to, just by placing the sector carrier class antennas, they were able to achieve 15 to 20% improvement in a signal. CO2 goes up, noise floor went down across the whole all customers. And they also notice one thing, that when you put the customers at the edge of the sector, so usually you have a problem with the mismatch chains and it doesn't work, but not with these antennas. Even the customers that are on the edge of the sector, they have really good performance, and it's because the sector carrier class antennas has a balanced beam performance. So the beam performance for horizontal and vertical polarization is as close as possible. For example, they have a customer which are 16 kilometers far away, and the customers work perfect with these antennas. And also they don't need to use an RF armor. The sector carrier class antennas come with the backshield technology, and when they installed the antenna, it took 1/3 of the time usually necessary for an installation. So they really find what they were looking for, and they decide to build another site just by using a sector carrier class antenna. And this is the picture of such a site. So in the red circle you can see 4 sector carrier class antennas which are covering the area all around this hill. So this was the use case of Blue Spam Wireless, or WISP, in the US. But if you are looking for more feedbacks from the customer, you can join our community. So it's rfelab.com. The registration is of course for free. You can join there, and you can see what other customers are telling about our antennas, as well as if you have already some experience with the sector carrier class antennas or other RF Elements products, you can go there and leave the feedback there. Even if you have a question, you can ask it on the community, and we will answer it very short. So we are on all major social networks, so LinkedIn, Google+, Facebook, Twitter. We have also our YouTube channel where you can check also our videos. We started to publish feedbacks from customers, so for their experience with our products as a video, so you can check our YouTube channel. There are already customers, even the guy from Blue Spam Wireless is talking about their experience and what they achieved, so you can check it on the YouTube channel of RF Elements. So also that was all from my side. So now it's time for questions if there are any.
Thank you, Mikael. That was very informative. We have one question here. One that's wondering if you have any best practice in regards of the mounting of the antenna in the tower in regards of distance between the antennas horizontally and vertically. Is there any best practice?
So as you can see on this picture, so you can mount it like this. So on the tower, you don't need to worry too much about the distance. I mean, still there need to be a distance, but not very big. Actually, I can go back and show you the. This is the picture how they install it, and also people were asking why why so far from each other, and the reason for this was that it was already built before they choose the sector carrier class antenna. So definitely you can go closer than this. So you don't need to worry about the back radiation or the side lobes. So if you mount it on the tower, if you have a 3-poles tower, you can mount it there and it shouldn't be a problem.
Okay, thank you. Any more questions? No? So far? Okay, Mikael, I will go switch over to Norwegian on the last part here.
Okay.
And take over the presentation. Okay? Thank you so far.
Yes, so thank you everybody that you come.
Da har jeg bare lyst til å nevne at vi kjører kampanje på RF Elements sine produkter ut mai, 15% rabatt på produktene. Det du må huske på å gjøre, det er å merke ordre med webinar 10.05.16. Så for dere som deltar på webinarene, så kjører vi det spesialtilbudet her. Ellers så vil jeg bare minne også om at vi har et nytt webinar med RF Elements i den 18. mai klokka 09.00. Det er vel kanskje noen som er litt rystende da, men vi får nå Håper at dere finner det interessant og har lyst til å delta. Det er bare å gå på avantis.no/seminar og melde seg på. Da blir det snakk om integration platforms. Og avslutningsvis bare minne om webshop-adresse, og er det behov for noe presalg-bistand, så send en mail til salget av Avantis eller ring oss. Og tekniske spørsmål relatert til løsninger, så er det bare å kontakte support etter Avantis. Så skal vi prøve å følge opp, og kan ikke vi svare, så tar vi kontakt med RF Elements og får hjelp av de. Da vil jeg bare takke dere for at dere tok dere tid. Håper dere fant presentasjonen nyttig, og at vi ser dere igjen 18. mai. Takk for nå.